Hello students and welcome to my YouTube channel. Today's our video is for class 9 and we will discuss on the topic current electricity. In this video we'll discuss on the certain topics, that is free electrons, flow of current through the conductor, Ohm's law, resistance and the resistivity of material. So let's start. Our first point is free electrons. Regarding the electrons, electrons are what? These are the negative charge particles. But what when the electrons becomes free? Generally, in any electric field, the region around the charge particles within which other charge particles experience attractive force or any certain force between two charge particles. When these valence electrons, these are generally loosely bounded to the nucleus because of their larger distance. When any external force or any external energy, that is in form of heat or in form of light, is applied on these valence electrons, and due to their force they get pulled away from their parent atom and they becomes free. And whatever they becomes free, so that's why they are called as the free electrons. And due to these moving charges, these free electrons are also called as a moving particles or moving charges. And these moving free electrons, they transmit the electric current through the conductor from one point to other point. So how they will transmit? Let's see here. Here in this topic, we'll see how the current flows through the wire or through the conductor. For that we have shown here two diagrams. In first diagram here, one conductor is being shown. Let's consider it as a metal wire. When any particular metal wire is as it is placed, whatever are the electrons which generally are free electrons, as we discuss here, they move in a random manner when they are free, when there are no any external forces applied. But as soon as, if you see in this second figure, what we are doing, when we apply a external force, that is here we have applied a force, that is a cell we have applied. As soon as we applied the electric force, as soon as we applied the force, that is cell, what happens? Whatever are these electrons, they have get certain direction, and due to their negative in nature, they start to move from negative to positive terminal. And what about this conventional current? Generally, this conventional current, they flows from higher potential to lower potential. So that's why this flow positive is a higher potential. So conventional current will start to flow from positive terminal to the negative terminal, and this way this current flow of the direction. Electric current is same, the flow of charged particles. Now whatever these charged particles which are flowing through this conductor are called as a electric current. What is current then? Current is a charge passing through a conductor in a unit time. Now whatever is the charged particles are flowing, they will require certain time to move from this point to this point. That is a current. Generally current we denote with the symbol I. How to find out the current? We will use this formula to finding out the current. Current is what? Charge passing through in unit time, that is I is equal to Q upon T, where Q denotes the charge and T denotes the time. To measure this, we have certain SI units also, where current, that is I, is measured in ampere, whereas the charge is measured in coulomb. And for time, we know time is measured in seconds. Next point is Ohm's law. Generally, Ohm's law is a relation between the current flowing through the wire and the potential difference applied across the two ends of the conductor, and their relation is given by the law called as the Ohm's law. The statement of the Ohm's law is, if the physical state of a conductor remains constant, then the current flowing through it is directly proportional to the potential difference applied across the two ends of the conductor. Mathematically, how we write this statement as current is proportional to potential difference, that is I proportional to V. But when we talk about the physical state, what the physical state signifies here? Physical state indicates the length of conductor, either the area of the conductor or also the temperature of the conductor. If they are constant, then these two are proportional. Then when I is proportional to V. Now to equate this proportionality sign, we have to use some constant value. So we use here K, that is I is equal to KV, which is a constant of proportionality. Then we'll change this K to other side. So I into 1 upon K is equal to V. Now this 1 upon K actually is a resistance which is flowing through it. So instead of this we use R. So the equation will become V is equal to IR. Next is your resistance and the resistivity. Resistance is the property of material by which it opposes the flow of current. This resistance depends upon certain factors. What are these factors? Length of a conductor, area of the cross section, and nature of the material. Let's discuss one by one how this resistance depends upon these factors. First factor is length of a conductor. When a length of any conductor increases, the electron will have to suffer more collision while traveling from one point to other point. Their resistance of a conductor increases with increase in length. Second factor, that is area of cross section. When electron passes through small area, they suffer more collision and hence resistance to flow of electron is more. On the other hand, when electron passes through larger area, electron have to suffer less collision and hence resistance of flow of electron is less here. Third factor is of the material. If the materials are different, then whatever the electrons to flow, it will also suffer different types of areas. Now the different material have different types of resistance, so it will also be a factor. Actually, resistivity of a material is a resistance offered by a conductor having unit length and the area of cross section. Resistivity is a characteristics property of a material and it does not depend on a conductor and the area of cross section. Different material have different resistivity. Let's see mathematically what is the resistivity. As we see that resistance depends upon the certain conductors, that it depends upon the length. So R is proportional to L. It also depends upon the area, that is R inversely proportional to area 1 upon 8. By equating both these equations, we get R proportional to length upon area. To equate this again proportionality sign, we have to use certain constant value. So we use here rho, that is R is equal to rho into 1 upon A. So rho is what? It is actually a constant of proportionality. Now to measure this resistivity, we have certain SI units. It is measured in a ohm meter. Next part of this lesson we'll see in a next video. Thank you.